How does temperature affect an equilibrium? Well, remember we talked about endothermic reactions and exothermic reactions, right? And the prefix tells us whether the heat is coming in or going out. So exothermic means heat is going out. So an exothermic reaction, we can think of heat as being a product. So if we had A plus B in equilibrium with C, and this was an exothermic reaction, that would mean that when the reaction went in the forward direction, it would release heat. It would produce heat. Heat is a product. Okay? So if we think of heat as a product, then we can answer questions about this equilibrium with temperature changes. If we raise the temperature of an exothermic reaction, that's like adding heat. Well, heat is on the product side. If we add a product, how does the equilibrium shift? It shifts towards the reactants. What if we took this exothermic reaction and we cooled it down? That's like removing heat. If we remove heat, the reaction will shift to replace it. Endothermic reaction, we can think of heat as a reactant. So we take A plus B, and we have to put energy in. You have to put energy into it. So energy is a reactant. You have to put energy in. So then, if we increase the temperature, that's like adding reactant. The equilibrium will shift away from that. If we cool it down, that's removing heat, and that will cause the reaction to shift to the left. This idea is used in industry because in industry, if you're doing a chemical reaction to make a product, you want as much product as possible to form from your reactants. And so by controlling the temperature of the reaction, you can shift the equilibrium to do what's good for you, which is to make more product. Okay, so I kind of already did this, but here's a specific example. An exothermic reaction. We add heat, reaction shifts to the left. We take heat away, reaction shifts to the right. So you remember what happens with reactants and products when you're increasing concentration or decreasing concentration. You just write heat in as a reactant or a product, depending on whether it's an exothermic or endothermic reaction. Then you use exactly the same thought process to decide which direction the equilibrium will shift. Here's an endothermic reaction. N2O4 is a colorless gas. It is in equilibrium with NO2, which is brown in color. And this is an endothermic reaction, so when the forward reaction occurs, it absorbs heat. So if we add heat, the reaction shifts to the right. If we remove heat, the reaction shifts to the left. Adding or removing heat is changing the temperature of the substance. So, you want to boil water. That's an endothermic process. You put the pot of water on the stove and you turn on the heat, right? And you put heat into it. You're increasing the temperature, you're adding heat. So this is a really cool, I wish I had one of these tubes because it's just so fun to play with. But this is a sealed glass tube containing N2O4 and NO2. And so here we have, in a warm situation, so it's in a hot water bath, and we see that it shifts and turns brown. The equilibrium is shifting to the right, to the products, because heat is a reactant for this. If we take that same tube, it's still sealed up, and we put it in cold water, the color goes away. We can actually see this shift because one of the gases is brown and one is colorless. And so when we cool it down, we're removing heat, and that causes the equilibrium to shift to the reactants. Any questions? So there's summary. I don't think I need to read that to you. Let's look at this example. Oh, we saw this guy before, didn't we? The following reaction is exothermic. Is heat a reactant or a product in this? It's a product. Exothermic means heat is exiting, it's being given off, it's being produced. So actually write it in there before you look at the question. What's the effect of increasing the temperature? Well, if I'm increasing the temperature, am I adding heat or removing heat? Adding heat. Increasing the temperature is adding heat. Which direction will the equilibrium shift? To the left. What if I decrease the temperature? To the right. Because if I'm taking this away, it will shift to replace it. So at least this part doesn't really have any numbers in it, right? So for some of you, it's like, oh, yay, no numbers. And others of you, oh, shoot, I like the numbers. This whole thinking thing, I'm not so sure about.